Welcome back to the channel, where we decode the universe. If you thought 2026 was just a year of better cameras and clearer skies, think again. Today, we are diving deep into the mind-bending breakthroughs that have shattered our understanding of reality this past year alone. From planets colliding in real time to the first confirmed ultraviolet glow from a galaxy born mere billion years after the Big Bang, the cosmic race has accelerated faster than ever before. In just 12 minutes, you will witness how humanity is finally catching up to the cosmos itself, uncovering secrets about the very fabric of space and time that have eluded us for centuries. Are you ready to see what lies beyond? Let's start with something that feels less like science fiction and more like a live-action thriller. For years, we've known that stars can collide, but seeing it happen in real time was always considered the domain of theoretical simulations. In early 2026, astronomers using a newly synchronized network of telescopes across 3 continents recorded a direct collision between 2 gas giants. It wasn't just a merger. It was a violent dance of gravity and momentum that rippled through the local star cluster with terrifying precision. The event, dubbed the Double Planet Incident, provided unprecedented data on how planetary systems evolve during their chaotic youth. By tracking the debris field and the gravitational waves emitted during the impact, researchers were able to model the life cycle of these massive objects with an accuracy never before achieved. This discovery fundamentally changes our understanding of planet formation, suggesting that our own solar system might have been much more turbulent than we ever imagined during its infancy. While the planetary collision was spectacular in terms of visual drama, the physics behind it offered even stranger insights. Shortly after the announcement, scientists traced a mysterious surge of low-energy gamma rays back to zinc-70 nuclei, undergoing magnetic changes deep inside their structure. This breakthrough allowed researchers to observe nuclear processes occurring within stars and supernovae as they happen, rather than just inferring them from ancient debris. The implications are staggering. It means we can now predict stellar evolution with a level of certainty that was previously impossible. We no longer have to guess how long a star lives or what happens when it dies, because the light itself is telling us the story in real time. This shift from passive observation to active participation in understanding nuclear physics marks a pivotal moment in our ability to decode the energy that powers the universe. But perhaps the most profound discovery came from looking back at the very beginning of time. For decades, we struggled to find evidence of galaxies existing just 1 billion years after the Big Bang. Until recently, these early structures were thought to be too faint or obscured by dust for our telescopes to catch a clear glimpse. However, the collaboration between NASA, ESA, and the CSA finally captured what they described as the first confirmed ultraviolet light from such an ancient galaxy. The discovery reveals that massive star clusters emerged remarkably quickly from primordial clouds, clearing away gas at an alarming speed and flooding the early universe with intense ultraviolet radiation. This challenges the prevailing models of galactic growth, suggesting that the universe was far more active and chaotic in its infancy than we ever could have imagined based on older data sets. So what does this mean for us moving forward? These findings aren't just academic curiosities. They represent a new era where our tools are finally capable of witnessing history as it unfolds rather than just reading its remnants. The ability to track planetary collisions, observe nuclear transitions in real time, and see the first light of ancient galaxies means we are entering an age of predictive astronomy. We can now model future stellar events with high confidence, anticipate gravitational anomalies before they occur, and even begin to understand how these early galactic environments might have seeded the complex chemistry necessary for life elsewhere in the cosmos. The practical takeaway is clear. Our window into the universe is opening wider every day, offering insights that could reshape everything from energy production models to our understanding of biological origins across the galaxy. From colliding giants to ancient ultraviolet whispers, 2026 has been a year where the boundaries of human knowledge were pushed further than ever before. The universe is no longer just a distant mystery. It is becoming increasingly accessible and understandable through our relentless pursuit of discovery. If you want to dive deeper into these cosmic mysteries, or see how they impact your daily life, make sure to hit that subscribe button and join our community of curious minds. Drop a comment below telling us which breakthrough sparked the most wonder in your mind, whether it was the violent dance of planets or the silent glow of ancient stars. Until next time, keep looking up